So in the last video, we set up this analytical rendering environment, and we set our output gamma to 1.0, which resulted in an image that looks exactly like the input. The energy that comes out of our input exactly comes out the way that it looks. So the actual image looks just like the rendering. Good. We also established that if we set this output gamma up to 2.2, for example, then everything gets brighter for some reason, and that's generally not what we want. Usually we want input images to match the output images. Or if we set this to 0.45, for example, it's going to get really, really dark. And why am I choosing those numbers in particular? Well, it's somewhat arbitrary and somewhat not, but we're not going to get into all of the details here, okay? But let's just talk through this at a high level. So here's the basic idea. Some people think that gamma is about monitors and electricity and all that kind of stuff, and to a certain extent it is, kind of. I mean, gammas used to be based on trying to get monitors to look more like printers, you know, and printers and monitors were pretty known things at the time, and so you just kind of hard-coded that stuff in. These days, that's not relevant. The actual reason that gamma encoding still exists is this. When a camera takes a photo, your CCD is going to register a certain amount of energy as 0, or black. And then you have another amount of energy that registers as 1, or white, right? And then in between there, you're going to have this linear relationship, so that anything in between there, dead in the middle, is going to be a 0.5, right? That just makes sense. It's obvious. A certain amount of energy is white, a certain amount of energy is black, 0.5 is right in the middle. Duh. Well, actually, though, the problem with that is that human sensitivity to light is logarithmic. Just like human hearing, if you're familiar at all with sound and the way that sound works, you'll know that decibels are a log scale, so that every doubling of the amount of sound energy actually only sounds a little bit louder to a human. It doesn't sound twice as loud. The same thing is true with light, albeit on a different scale. So, twice as much energy doesn't mean twice as bright for human vision. So in practical application, what that means is that when your CCD takes an image, it's going to capture a whole bunch of stuff up here at the top to which your eyes are not sensitive. You just won't be able to see it. So all of these valuable bits and bytes are completely useless to us. Whereas down here, this part, turns out we're extremely sensitive to. And so all of those bits and bytes that are used up here aren't being used down here. We have a linear amount, and so actually we're going to get banding down here. We're going to visibly see some artifacts in these areas when they actually look right on screen. So the clever people, clever science people, came up with this idea that they would apply an encoding gamma to their CCD. So what we do is we basically darken the whole image. By looking at this, we're saying this up here is a white pixel, certain amount of energy, that gets us a 1. Certain amount of energy gets us a 0, or a black pixel. But instead of assigning a 0.5 right in the middle, we're actually going to assign something much lower. We're actually going to darken the image. And this stuff up here, this stuff that we couldn't even see, everything above here is just, you know, it's just white. You can't see it. That stuff, we're going to darken it so that you can see it. And then this stuff down here, we have tons of data. All this stuff, instead of being linear, we're actually getting lots of extra bits and bytes down here. We're effectively taking all of this wasted stuff up here, and we're going to make it useful to us down here. So this encoding gamma is actually a critical component to the way that electronics, like digital cameras, work, but also virtual cameras, like Moto's camera, are going to apply an encoding gamma to their images because they want to take advantage of those extra bits and bytes down here in the visible spectrum, rather than wasting them up on stuff that we won't be able to see anyway. So everything to the left of this line I've drawn here, we cannot control, okay? This is what the camera does, this is what Moto's camera does, this is what all kinds of input apparatuses do. They're going to apply some kind of encoding gamma. All of them are slightly different. But then on this side, this is what we actually get to control. So when we set a gamma display, a display gamma I should say, of 1.0, that's going to be a linear relationship. It's going to take exactly what we're getting from this side and display it on our monitor. And since when we applied that gamma, it made everything super dark, A value of 1.0 is going to make everything super dark on our screen. We got lots and lots of black down here, and the whites look all compressed up top. That's not ideal. So what we do is kind of weird. We actually apply a display gamma. So what we typically do is we have an encoding gamma that we can't control over here, and we apply its inverse before we display it. What that does, it's really clever. You see, we've gained a whole bunch of detail down here in the low area. We've lost detail up here, but we don't care. And then when we display that gamma, we just take all of that detail that we gained down here, and we're just going to move it up to where to the visible spectrum where we can see it, right up here. So we end up with what appears to be a linear gradient. We've started with black at the bottom. We've got white at the top, or 1, and then right in the middle is what is visually halfway between. So this sounds a little bit crazy. I know that this sounds really convoluted, and frankly it is, but the fact is it's necessary. It's the way that human brains work. So to understand how to use gamma, we have to know that gamma is effectively being applied twice. We have an encoding gamma, we have a display gamma. All right? So let's talk about what that ends up meaning in practical application.